Hi, this is Beale. I'm going to show you a fun Kubernetes attack path today. It's freezing here at the North Pole, even inside Jack Frost's casino. So let's take our mind off it and hack Jack Frost's Kubernetes cluster. Okay, here's the story. Jack Frost is cheating the casino players using a Kubernetes cluster to coordinate the games in the casino. It's querying his vendor's Casino Monitor 1225, which tracks the players' winnings against their initial chip purchase. If they're up by 50%, the cluster directs all the casino games to cheat the player, skewing the odds until the player is below 50% again. So this doesn't sound very good. So let's see if we can set things right. We're going to get right into a demo. So here we go. So we've got Jack Frost's Kubernetes cluster. We've got just one port it's listening on, and on that one port we find a web server. So let's try an old pen test trick and hit robots.txt. See that it says please don't hit contractors.php, and we'll go hit contractors.php. And when we look at this, it basically says, hey, we're some wronged contractors who got stiffed by Jack Frost. He's frozen out too many of us. The contractors built the computer systems, so let's see if we can stop Jack Frost from cheating the casino patrons the way he cheated us. So we're just going to check and see if this thing just lets us run commands. So we type ID. Yep, this is a web shell. So we're going to turn around and make this pull down an interpreter binary from our Kali Linux's web server. And that's going to get us some interpreter session running right in that first pod, in the contractors pod. And we set up a quick little shell. I'm going to do one more thing with the web shell first, though. I'm going to run env for environment, and that's going to give us a bunch of services. Now, Kubernetes services are kind of load balancers. They can be external, like that contractors one was, or they can be internal. So if we're looking at the environment variables, anything that was any of the services that are in the same namespace as our pod are going to have the services listed out as environment variables with IP addresses even. So we find the interesting one here is this SKU level service host, the SKU level service, and here's its IP address, and it's on port 80. So let's go and take that IP address and curl it. So we'll curl that IP address from our contractors pod, and we see a JSON object, and it's a bunch of players, and we have a player Kate Libby whose win rate is 90%, and so the casino is going to skew things against her by 10%, and you see a bunch of the other players here. So this is what we're trying to break. We're trying to break the casino cheating. So we're going to upload a copy of kubectl and go back to our shell in that pod. And what we're going to do is find that if we look in that pod, there's an auto-mounted service count token in var run secrets Kubernetes IO. And so you'll see if you look in one of these service count directories, I'm just going to set a variable to that service count directory. If we look in that service count directory, we'll see a certificate authority cert, a namespace, and a token. That token's a JWT, a service count token for this pod's service count. So if we look at the namespace, we see we're in the default namespace, and what we can do is just set up a kubectl command that's going to have all of the values we need. The certificate authority path will be among them. So we'll set up an alias for kubectl that says use the token, use that JWT we saw, use the certificate authority path we just found, use the, and for server, just the traditional DNS name, core DNS name that's going to get us to what we need. So we'll make kubectl executable, and we'll run kubectl versions, see that we've got a cluster version that's not out of date. We'll do get pods, and we'll see that in this namespace we've got that contractors pod that we're already in. We've got a SKU level pod, which is where that service is actually pointing. So let's go and say kubectl describe pod SKU level and see what we learn about it. We find a specific image. This is going to be a public Bustakube Holiday Hack Challenge 2021 SKU level pod image, a SKU level container image. It gets passed in a couple environment variables. One of them is called monitor, and that monitor is that casino monitor.pitmme.com. That's for person in the middle me. And then Redis password. But Redis password, we can't see the contents because the contents of Redis password are in a secret called Redis PWD. So we can try and get that secret. We try listing secrets, and we're not allowed to list it. I'll tell you that if we tried to get that secret, we aren't allowed to do that either. So we're going to turn around and try something else. We're going to go and pull a copy of that container image. And because it was public, we're able to just pull it straight to our own Kali system. And now we'll run a container based on the image so we can kind of explore its file system. And the cool thing is we're going to do something a little bit better than just exploring its file system, you know, in the running container. Turns out that we're going to take that, that container, find secrets, and we'll run docker inspect. And this is going to show us that this container image is actually built up from a bunch of layers, and each of the layers is basically a diff and introduces some file changes, and they're all mounted, they're union mounted together in an overlay file system, and it's pretty cool. What that means is, similar to Git, nothing's truly ever gone. In here, if you make a change in the file system and then you make it, and you publish that container image, and then from that container image you make another change, they're all the changes you ever made are there, even if they overwrite each other. And by there, I mean we get them all when we pull down that container image, and you're going to see that now. So if we, this is everything between the colons are these different images, and you see from that those diff directories. So let's go and take a look at the things that were named in there. Let's take one layer of that image, and we see it's got a diff directory, and that diff directory has Redis password, and this is just deleting the Redis password that was in the image prior to this. So let's look at an earlier point in the image and look at its diff, and there we see there's a Redis password in it, and we can cat that Redis password out. So we've got this password that wouldn't show up in the image if you just pull it and look at it, but if you go and look at the layers, you find it, and Bob's your uncle. So let's go and play with this. The next thing I want to do is, now that we have this Redis password, I want to see if I can find a service. And so I'm going to upload an open source tool that some of us in Guardian started writing, called Paratis. And Paratis got a cool little feature we just added recently. So I've uploaded that Paratis into the contractor's pod, and I'm just going to run this enumerate DNS. It's a recent feature, and what it does is it makes a simple SRV DNS request for any.any.service.cluster.local, and that gets us a list of all the services and their IP addresses and their ports. So we see there's SKU level service and contractor service, things we were expecting, but there's also redis.control. That means the control namespace. So in the control namespace, which we didn't know about yet, that's a new namespace besides default or kube system, there's Redis, and there's also dashboard. So let's hit that dashboard first, because it's on port 80, and that could be interesting. So we'll exit out of Paratis, and we'll set up a port forward to port forward R8813 into port 80 on that service. And then we'll hit this in our browser, and we'll see this dashboard's giving us the same information that API gave us. We see each of the users. Kate Libby's got a win rate of 90, and SKU being applied to her. Casino's cheating against her by 10. So let's go and pull up this Redis CLI. Now it turns out that the dashboard and the Redis server are both running in the same container, and let's just stipulate that we figured that out and go make use of it. So we're using Redis CLI and hitting that Redis service by name. We're using the password we found, and now what we're going to do is tell Redis that its database file is in var_dub_html, and it's called shell.php, and we're going to use that to create a web shell. So flush all will empty the database, and then we'll set one key to some PHP, that runs CMD, that runs whatever command is passed in on the get, on the get CMD parameter. It just runs it. And this was in Holiday Heck Challenge last year in one of the terminal games. So we'll create this. We'll create this key. We'll hit save and exit, and now that means that we've created this shell.php. So let's go and curl that dashboard on shell.php, pass in command equal to ID, and it worked. We've got users. So we'll do -s for silent mode, and now let's try a more complicated version. And this complicated version is just going to run a interpreter. It's going to pull down and run a interpreter binary, just like we did with the first web application we saw here. So let's go interact with that pod that we're in, with the one that's running Redis. And we just set up a terminal variable, and now we'll clear. And so if we take a look, we see a flag. We can go read the flag to get a hint. It says, hey, you could replace the skew amounts, the cheating amounts in the Redis database, but they'll get overwritten, because the way this thing actually works is there's a skew level API, and that was that thing we saw in the default namespace, and it populates the skew amounts by checking the win rates with this API that isn't hosted in the cluster, that casino monitor one. And so it says, listen, if you can person in the middle this API, the casino monitor API, then you could break this. And so that's what we're going to do, because there's a cool CVE in Kubernetes that's kind of almost a feature. There are workarounds being introduced, but this is just kind of a function, and so it wasn't quickly and easily patched when it was found last year. So let's first, so that we can person in the middle of this, let's just interact with the API so we know what it's supposed to be sending out, so that we can send out something that's similar. So we do this curl against that API, against up or down. It says you need a player name, so let's go grab that player name right off the dashboard, Kate Libby, and throw that in, kate.libby. We get back an answer, 90. Okay, so this API is just giving win rate. It's not giving skew. It's nice and simple. So that means that if we can person in the middle of this, we can make it so that we control what win rate the Kubernetes cluster is seeing, and thus whether it'll cheat or not. So we've got our kube control setup that we do, and in this player DB in the Redis pod. And now we say, okay, in the default namespace, give me a list of all the things that I can do. We use auth can I, and we get back, hey, for services, you're allowed to create them and get them and list them. Well, that's cool. So let's use our privileges to do that. First, let's take a look at the services that are there. There's a contractor service, and we're going to use the contractor service so that we can get the traffic that we're going to create. We're going to create our own service. We want to send its traffic to the same place the contractor service goes, because the contractor's pod is the one that we've got code execution in, where we can affect how it responds to requests. So if we look at this contractor service, there's a selector, and that's what controls where the traffic goes. It goes to any pods where app is set to contractors. So in our service, we just have to set the same selector. So we're going to create our own service. I'm uploading it. I've built it already, and I'm going to show you that service. Here we go. So the service is kind service. It's got a name. That name doesn't matter so much. What matters here is what's in the spec. So the external IPs, anything going to these IPs, and this is the IP address that DNS name maps to, is going to instead be sent to pods in the cluster with app set to contractors, and it's going to be only for things that we're going to port 80 on that external IP, and they'll instead go to port 8000 on those pods. So if we apply this, if we can create this service, we're able to person in the middle anything from this namespace going out to that external IP outside the cluster. It's not going to go to the outside. It's going to go instead to what we want it to go to. So now that we've got that set up, we need to go back over to the contractors pod and set up answers for any of the incoming requests we get. So we're going to do a quick little thing. We're going to say, wait, if all the requests are going to be against these users, this is kind of the simplest way to do it, these URLs are going to be slash up or down slash, kate.libby or dave.murphy. Well, let's just take these and we'll create a little loop. And we're just going to create a directory. We create a directory called up or down. We create a file for each of these users in the directory. And if you look at the contents of one of these files, we'll look at the one for Dave Murphy, it just returns 5. So not that complex an API, but now if you hit SKU level goes and queries the SKU level program you're interacting with here, goes and queries that external IP, but it gets rerouted to us, so we're person in the middling it, and now everybody shows up with a win rate of 5, which means they get a SKU, a cheating of 0, no cheating, and that means we're kind of saving the day. So when we reload this dashboard, we see 5, we see 0, and things are good. We were victorious. Okay, some resources you might find helpful. The first link is Kubernetes, the tool we used here. It's got a lot more features, and we'd love your help developing it. The CVE is the second link that led us to the person in the middle, external IP. The third link is the slides, which also contain an extra slide with a summary of the attack path. The fourth link is InGuardian's Kubernetes page, where you can find tools like Kubernetes and Bustakube, and videos, and other resources. And then finally, the last link is a YouTube link for a longer Kubernetes introduction talk. It's got some good introduction to how Kubernetes works, and then it's got its own really cool attack path themed on Scott Pilgrim versus the World, a classic movie. So anyway, I hope to see you around KringleCon. I know I'll be playing the Holiday Hack Challenge, so hopefully we'll meet each other virtually. Thank you so much for your time.